Welcome. Sorry, I didn't mean to blow your ears out in the front row. Welcome, everybody, to the last talk on the Wednesday of PDC. Glad everybody was able to recover from the party last night and stumble back on down to the convention center for the last few sessions of the day. My name's Matt Winkler. I'm a program manager in the Connected Systems division at Microsoft, where I get the very fortunate job of being able to focus on building a lot of the tools you'll see to build workflows. I want to start off with a little story to set some context, and I want to do that by rewinding the clock about 3 years to PDC 2005. And at the time, I was working for a small consulting company, and I didn't have the opportunity to come to PDC, but I remember sitting and watching Dennis Pillarinos give a session about workflow, and I remember looking at that and thinking, that's pretty cool. This is a pretty neat technology. I kind of dig this. I'd like to find out some more about it. And I think you have to be careful what you wish for, and don't ever believe people that tell you it doesn't rain in Seattle. But I was fortunate to end up at Microsoft, where I was the technical evangelist for workflow, working with a lot of customers trying to adopt workflow early on. Got to talk to a lot of people who started to use it, and got to talk to a couple people who didn't get to use it. And one of the things I'm really excited about with the work that we're doing in WF4.0 is a lot of the reasons people had some troubles with 3.0 around building activities. We've really done, I think, we've really addressed a lot of the issues people had. We've made it a lot simpler to build activities, and that's what we're going to be talking about today. A little bit of level setting for the talk. This is not going to be a workflow intro talk. Kind of made an assumption about the audience that most folks were either going to have used Workflow 3.0, so they'd be familiar with a couple of the things we'd be talking about, or they went to Kenny Wolf's WF4.0 A First Look. So, quick show of hands, how many folks are using Workflow today? Absolutely awesome. Cool. Just for the record and for the folks listening, about 90% of the room said yes. So we'll do a very brief overview just to set the universe in which custom activities exist. We'll go through, we'll talk about the theory of activities, and then we'll get to the code and we'll start building some activities. And we'll go through the simple scenarios, and then we'll get into some of the more fun stuff as we start to build custom composite activities and talk about error handling and all that good stuff. We'll then close on the topic of building activity designers, which is a topic that's kind of near and dear to my heart. So let's get started. What is workflow? Workflow at its core is about the organization and the coordination of work. We like to say we do this with minimal ceremony. And what we mean by that is that we can really see what the program's doing. And we push a lot of the hard stuff down into the runtime. Workflow consists of three things. We like that we've landed on the acronym ART. The alternatives are TAR and RAT, and we didn't think either one of those was too good. So workflow is a set of activities. Activities are the unit of work. They're the atom in our universe of programming. We take these activities, these units of work, we compose them into workflows. All a workflow is an organization of activities. Now, if we just did that, it'd be kind of interesting. It would sit there, we'd have some activities, but usually we want to do things with our programs. So we hand these workflows to a runtime. The runtime is what I mentioned earlier, that it takes care of a lot of the stuff of our program in terms of coordinating all of these things. But the runtime fundamentally is also pretty simple. Its job in life is to execute activities. And it's to make sure that our activities are well behaved. Now, in order to build these workflows, in order to build these activities, we also have a layer of tooling that sits on top of this that allow us to build workflows and activities. We can debug them as we're doing work to try and figure out what's going on in our application. And then we've got another pretty interesting use that we see a lot of folks interested in, which is rehosting our designer. The way to think about activities is that they're the vocabulary of our program. And sometimes what we want to do is be able to create a very constrained vocabulary for our program and be able to allow people to take those very few things that we have in our universe and compose them. And what we can do is take our workflow designer and we can actually rehost it inside another application that is not Visual Studio. At its heart, an activity consists of two things. This unit of work that we talked about, and then some data that we work upon. And this is a lens through which you can view an activity, no matter what that activity is going to do. We'll build some more complex and more sophisticated activities later in the talk, and those activities can do things like sit around and wait, and they can persist, and they can come back in a couple seconds, in an hour, in a week, in a month. But I can always go back to just viewing an activity as a unit of work that's going to be executed by my workflow runtime. So that's an important model to kind of keep in your head. And once we think about it that way, the activity is the unit that we then compose with other activities to form our workflows. So now out of the box, if you go and you install the .NET Framework 4.0, and you navigate through your favorite tool like Reflector to system.workflowmodel.activities, you're going to find a few activities in there. You'll sometimes hear us refer to these as the out-of-box activities. And what these activities really represent to us is the kind of fundamental things that you might want to do with your program. But this is just the beginning. We have a number of control flow activities. These are activities that allow us to arrange our activities with some expected execution semantic, whether that's simply in sequence, I want to do A and then B and make a decision on C or D, or something more complex like a flowchart or a state machine. On top of this, we have our base activity library. These, again, are kind of fundamental things that one needs if they want to start to build some interesting programs. And on top of this, we have partners throughout Microsoft that are building these, and the purpose of this talk is to talk about extending this and you building your own custom activities. Why do I want to build a custom activity? When should I build a custom activity? Start with the why. Really, you're creating the units of work that you want to have in your programs. You're creating the vocabulary that others will use to build a program. Now, you might also just want to create some unit of work that's not in the box. So we have database activity and service, but you want to go and talk to your CRM system, for instance. So an activity is a very natural unit of encapsulation around some other functionality. The other reason you might want to write a custom activity is to model a custom control flow. Now, why might you want to model a custom control flow? Well, one thing we saw a lot of folks doing in 3.0 and 3.5, we had two control flow models that we shipped, sequence and state machine. And it was pretty amazing the hoops people would jump through to try and capture their process inside of a sequence or a state machine. And they would really start to do some pretty, you get these giant series of very, very nested loops of people trying to model their process. And one thing that we never intended was for workflow for any of the activities to be considered a closed set, including the control flow activities. And so you might want to write a custom control flow activity if you start finding yourself kind of doing some funny things, trying to squeeze into a flowchart or a sequence. With that, let's go ahead and jump over, and we're going to write an activity. So I'm going to start off inside Visual Studio. I'm going to walk up to my project, and I'm going to say that I'd like to add a new item. This is going to come up with a list of things that I can add to the project, and what I'm interested in is adding an activity. And we will call this the PDC demo activity. This is going to do a little bit of work, and what we're going to see is the canvas for designing our activity. And there's nothing in here right now. And the primary model that we have to build activities is to compose them out of other activities. If you think we have this kind of this broad library of activities, you'll write a number of other activities, and it becomes very natural to express your activity as, I want to do a little bit of database work, and then I want to update my CRM system, and then I want to call these 3 web services. And so this idea of activities composing other activities is something I'm going to return to again and again. So we're going to go to our activity palette. And what we see here, so these are what we refer to as the out-of-box activities. And just a quick kind of caveat to let you know where we're at right now. These are primarily the ones that we've built design experiences for. This is not the ultimate exhaustive list of activities that we will ship. So if there's something on here, or if there's something you think should be on here that you don't see, come and talk to us, and it probably will eventually be on there. But we're going to go ahead and grab a sequence, because we want to do two things inside of our activity. We're going to go and get 2 web pages. I'm going to take an activity that I'll show how to write a little later on, where we go out to grab a web page. It's the HTTP GET. And let's go ahead and look at the properties of this guy. So we talked about work and we talked about data. The work is I'm going to go get a web page. And the data are 2 things. The URL that I want to go get and the HTML text that's going to be returned. Now my mother's a very, very wise woman. And she once told me, I was probably in 2nd or 3rd grade, if you're ever doing a demo that involves network access, always use localhost. Like I said, my mother is a very, very wise woman. So that's what I'm going to do. I'm going to use localhost, and we need to quote our strings here. So I'm going to go out to localhost whack Microsoft, and then I am going to go off to, in this activity, actually, you know what? For this activity, I want to do something a little different. It doesn't make sense to define all of our data within an activity. Oftentimes, I want people to be able to pass me data. So what I'm going to do, I'm going to go ahead and create an argument. Call this website 1. And then for my HTTP GET activity, I'm going to use the argument website 1. And so what that'll do, this one's going to go off and get HTTP localhost whack Microsoft, and the second one's going to go and get whatever I ask it to. Let's go and look at how we invoke our activity, how we execute our activity. Now, if you're familiar with 3.0 and 3.5, this top commented out section of code is going to look pretty familiar to you. You're going to create a workflow instance. We then have to do a little bit of work with an auto reset event because I want it to stick around until it's done executing. And I had to wire up the completed event here, and then I have to go and say start. And the reason I need to do all of this is when I spin this workflow instance up, it's going to be on a different thread, and normally, most of the time, a console app is going to then just keep on going if you spin something up on another thread. And one thing that we had heard from customers was that, okay, this is good, this is a nice model, but very often I want a very simple way to invoke my activity. Really, and the one thing that we got asked about a lot is how do I unit test an activity? Right, this is kind of a lot of machinery to spin up this runtime and then do this threading stuff and to write a bunch of unit tests. And so one of the things that we've done, we allow you to directly invoke an activity. And so all I need to do is walk up to Workflow Invoker, and I need to say I want to create a new PDC demo activity. And then I pass in the arguments that I want. And let's see, so I only need website 1, and we'll change this to get localhost mwinkle. And we don't need website 2. So let's go ahead and see what happens. And let me do one other thing. I'm going to go ahead on this activity and set a breakpoint. Because I want to find out what's going on. I'm really concerned that I'm going to be able to go and get these 2 web pages. And so I want to stop and see what's going on and when I do that. We're going to hit F5. This is going to build. And after this builds, we're going to spin up a console app. Console app is going to invoke this activity, passing in the data that we talked about earlier, passing in this one website that I want to go and get. Now, this is the part, okay, our build has succeeded. Because I have kind of a larger project, the build does take a little while. And we're going to spin up this console app here shortly. We're getting there, we're getting there. If this takes too much longer, I'm going to be forced to start doing my interpretive dance of an activity as I walk through the activity's life cycle. I'd prefer not to do that. I'm really getting no choice. So, all right, here we go. Right? Oh, good. Everybody has been saved from the dance of the activity. So, this is spinning up. We're going to go ahead and invoke this guy. And then what we'll see, ever so momentarily, and a quick disclaimer, the bits that I'm running right now have a number of different reasons why they're a little on the slower side. I think all of Visual Studio is a debug build, so this is something that will be faster in the real world. Okay, so I didn't hit the breakpoint there, but I went ahead and got out, grabbed localhost Microsoft, localhost mwinkle. I can promise you earlier today we did hit the breakpoint, and you're able to step through this and inspect all of the local variables and whatnot. Let's go ahead and switch back to the deck. And so let's talk a little bit more about the theory of activities. We kind of have this abstract definition of its data and work. Let's drill into this a little more. So the first form of data are these things that we call arguments. And the way that I think about arguments are the signature of the activity. These determine the shape. What data am I going to receive, and what data am I going to return? And arguments consist of three things. They consist of a direction, in, out. They consist of a type, string, date time, list of votes. And it's important to note that we can use really any type here. And the final thing that they'll consist of is a name, so that inside of my activity I can go ahead and use those. Now, the way to think about arguments is that they really promise me that when I go and grab polling place, for instance, I'm going to have a value there, that someone has passed to me this bit of data. And in the previous example on the HTTP GET, we saw that we passed an argument from the host into the activity that we then passed to one of our child activities. But oftentimes I want to pass data between activities. Let's think about what we're talking about here. So I still have my collect votes. What am I going to do after I collect the votes? I'm going to analyze them. And what I need to do is after I collect the votes, I need to pass the votes into the analyze votes activity. Now let's think about how we want to do this. And in 3.0 and 3.5, what we wanted to do is we needed to bind these two values together. And the way that we did that, we just went ahead and opened up a binding dialog and pointed from analyze votes and said, hey, I want collect votes.votes. Now, it's pretty nice in this local case where it's self-contained, but we didn't have any containment or scoping of variables. So I could do some kind of funny things, like walk up from a random point in the workflow and say, hey, I want to use collect votes.votes. That sounds really good. And this created workflows that were kind of hard to understand, where it was hard to really understand what is the life of my data. And so we've gotten a little more crisp in how we think about data within an activity, and we formalize that as a variable. Similar to an activity, similar to an argument, we've got the type here. And I use these variables as storage for data. And so what I'll do, once my collect votes is done, I'm going to say, hey, the outbound argument, I'm going to write that value into votes. And then in the next activity, on my inbound argument, I want to use votes. Now what's really nice about this is once sequence is done, I know I don't need to keep votes around anymore. I can go ahead and persist, and when I persist, I don't need to keep that state anymore, because we've now started to get a lot crisper about what is the life and what is the scope of the data within my workflow and within my activities. So now let's talk about work. And I really think of activities as having three different kinds of work. And the first is just simple, plain old atomic execution. I'm going to go ahead and start executing. I'm going to go and I'm going to calculate pi, and then I'm going to return that. And the way to think about this is really, this is for short-lived episodes of work. While this activity is executing like this, my workflow instance is going to be stuck right here. That's very important to be stuck right there because I want to go and calculate pi because I placed that activity inside my workflow. But where we need to start thinking about moving to the other forms of activity execution is as this work starts to be blocking. I wouldn't want to sit on a database call here and block my entire workflow execution while I go over a potentially slow network connection to go to a database and read a value. So what are the other kinds of work? Well, the second kind of work is, we've called it a couple of different things. You might hear people refer to it as reactive work or long running or continuation based. And the model to think of here is that I'm going to do a little bit of work, and then when I reach a certain point, I'm going to say, hey, I'm not done yet, but I don't have any additional work to do right now. The workflow runtime is going to take note of that and say, okay, this guy's still going on. He's waiting for something. And at some point in time, I'm going to walk back up to this bookmark. And all this bookmark is just a way to think about, this is how I say, I still have work to do. I'm waiting on something. Well, something's going to walk up to that bookmark and say, I would like to resume that bookmark. I want this activity to keep executing. And in this case, the activity that we have here, we're prompting. So presumably we wrote out, hey, what do you want to do? Then we sit back and we wait for somebody to type some input in saying, hey, let's go. And what happens while I'm waiting on this bookmark is that my workflow instance can keep executing. If we have other things to do in a parallel, for instance, or if we're listening for other things, my workflow instance is going to keep working. Now, if I don't have anything to do, we consider our workflow instance idle. And when our workflow instance is idle, we can do some nice things from a runtime perspective, like, hey, this doesn't need to sit around in memory. I'm going to go ahead and take this out and persist this to disk. So that in 3 weeks, when my boss approves my expense report, for instance, then I can walk right back up and pick this up where I left off. So when I resume that, we're going to pick back up where we left off, and then we're going to be done. And the final kind of work that we can do, you could call it a special case of the last one, but it's really composite execution. And that's where my activity is going to be responsible for executing other activities. And so this activity, call two friends, isn't going to complete until my two friends have been called. The way that this looks is as this activity starts to execute, it's going to say, I need to schedule two other activities, the call Ed and call Kenny activities. Now at this point, call two friends is done. It has, allow me to phrase that. Call two friends has no outstanding work to do. The workflow has some work to do. It needs to call Ed and call Kenny, but call two friends, now it's waiting for some work to get done. It's waiting for these two activities to get done, but it doesn't have anything else to do. So call two friends is going to say, hey, I'm done for right now. And at that point, call Ed and call Kenny are going to start happening. Now, assuming they pick up, nothing goes wrong, Ed and Kenny will pick up the phone. As they complete, call two friends can be notified of this. This gets interesting if I don't want to just wait for both call Ed and call Kenny, but in this case I do. And so after these two complete, call two friends could do some cleanup work, or it can be done. But it's important to note that call two friends cannot be done until any child activity it has is done. That's one of the things the workflow runtime is going to be pretty strict about. So I kind of talked about it a little bit on that last slide, but if there's one thing to really know about the system, it's the life cycle of an activity. Because again, fundamentally, the runtime is all about executing activities and making sure the activities adhere to their life cycle. And so what we're going to do, the activity life cycle is pretty simple. This is an area from 3.0 and 3.5 we looked at, and we said, there's some pretty decent opportunities to simplify this. And let's really try and reduce this to the core life cycle required. And what we found when we did that is we can actually layer some things on top of that that we used to have in the 3.0, 3.5 life cycle. So let's look at this, and then we'll come back to that idea. The initial state, this is my happy state. This is executing. This is where I spend all the time where I'm doing something. Now, if everything goes according to plan, I either have calculated pi, the activities I have scheduled have completed, the bookmark I had outstanding is resumed, I'm going to move into the closed state. And I'm done. This is what every activity aspires to be when it grows up. This is the happy path. But sometimes things will go wrong along the way. While I'm in the executing state, for instance, maybe when I'm calculating pi, I divide by 0. Not going to help me calculate pi. I'm going to move into a faulted state. And what's going to happen is whoever scheduled me is going to find out that I faulted. And in that way, we're going to let someone have the opportunity to handle that fault. Or maybe that we don't want to handle it. Maybe we want to let it bubble all the way out. The other thing that can happen, and this next one is really just plain rude, but I can be canceled. And this might be something that happens when, let's say I've got 3 activities executing in parallel. 2 of them are very well behaved. They're doing a little bit of work. They're on a nice path to get to closed. But then something goes wrong with the 3rd activity. And what's going to happen, the runtime is going to say, you know what, I need to cancel these other 2 because we're done with the workflow. And then I would move into the canceled state. And as I do that, I can go ahead and add some code there to handle, hey, something's going wrong. How do I fix it? So let's go ahead and dive a little deeper into building new activities. And so here I'm going to switch from coding on the fly to walking through some activities that I've written. The first is going to be find links. And what I'm going to do in find links is I'm going to use this HTTP GET that's going to go run out to a website. And then I'm going to hand it to the get links activity. All the get links activity does is that it is going to look over all the HTML that was returned and extract all of the links. So let's see what we've done here. So you'll see that we have a couple of arguments. We have found links. We have a direction of out. So I want my activity, I want the signature of my activity to be hand me a URL. I'm going to go do a bunch of work. And then return to me all of the links. And if we go and look at the type browser here, just want to make sure everybody was awake. Thanks for flashing the lights. What you'll see is that I can go through and find the types that I want. In this case, I am using a IEnumerable of WebLink. So I'm just going to return an IEnumerable for whoever calls me to use. Now, but I have this problem, right? I need to figure out how to pass these things around. Everybody can go back to sleep now. So my HTTP GET is going to, we can look at this, it's going to return some HTML text, and my get links has some text that it needs to operate on. And so what I'm going to do is create a variable on sequence called text. So I create the variable here, and then inside each of my activities you can see, hey, you have available to you this variable text. And the scoping rules that we're using here are just, hey, give me, for all of my parents, please tell me what your variables are. And so I have access to any of those. If I have multiple branches, I only have access to things that are in my direct chain of ancestors. So what we can do, and this is where this model of composing activities out of other activities gets really interesting, is I can really customize the level of abstraction that I want. So I've got these 2 very basic things. Go and get a web page, go and find web links. And I combine them into something a little more useful, but a little more abstract. And that's go and get me all of the links in that web page. What I can then do, because the problem I'm really trying to solve is that often I'm trying to get 2 sets of links. I always want to pull back the links from 2 different web pages because maybe I want to compare the results. What I can do then is take this find links activity, and I'm going to compose that and use that inside of another activity. And so what we're going to see here in just a moment is that I've composed these into a parallel. Because I want to execute these things at the same time. I don't want to sit around and wait. So there we are. Now what's really interesting about this, find links, I have no idea what the internal implementation is. Right? It's just as good as a black box to me right now. It's a unit of work, and I know that I'm putting it inside this parallel, and if I put 2 of them in parallel, whenever these complete, then I'm going to move to my next activity, which is going to concatenate the 2 IEnumerables. Okay. A couple other interesting things to show here. I've kind of talked about composing all these activities, but I haven't really dealt with what's the underlying form. And so the underlying form for these is just XAML. And so Dan Roth and Rob Relia are giving a talk, I believe, tomorrow morning about declarative programming in .NET with XAML. But what this gives us is a very easy thing that we can tool, that we can write our designer against, and a very easy way to express exactly what our activity is. And what an activity is it's just a type. And so you can even kind of, if you squint a little bit, it'll kind of come out and look just like C#. So I have an activity, that's the base class. I'm inheriting. I'm going to call it get two sets of links. I'm going to have some members. So in this case, I have results, which is an out argument, and you'll see that this is a type of IEnumerable of web link. And this is the part then where you really have to squint and kind of see what's going on. Now I have the sequence. I'm going to do two things in parallel, and then I'm going to concatenate those two. So this is our activity. So I've been able to take an activity and be able to fully describe it without having to drop down into code. So this is kind of interesting. But you say, I would really like to express this in code. Let's go ahead and take a look at what that would look like. So I have the in code two sets of links. I'm going to inherit from activity. I declare my out argument. And then in an activity, remember an activity is the composition of other activities. The important thing for me to do is to create the body. This is going to be the work that I want it to do. And again, if you kind of squint, and we take advantage of the object initialization syntax in C# 3.0 because we're building these nice hierarchical things, and so that helps us out. But I'm building a sequence. I have some variables, and then I have the activities that will execute inside of that sequence. I first have my parallel with my branches with find links and find links. And then I have concat IEnumerables. And you'll see I'm dealing with all of the data in the same way. I'm dealing with the in arguments and the variables, first website and second, or first web links and second web links. And the thing to think about as we build activities this way is how to take advantage of the activities that are in the box and the other activities that you've written. So for instance, if I needed to access a database, or if I needed to call out to PowerShell, if I wanted to interop with an activity that I wrote in 3.0 and 3.5, I can go ahead and do that by using those activities in my new activity that I'm building. So like I said, activity is really the primary way we think that people are going to author the units of execution. And the thing to think about the activity is that its execution logic is always expressed as other activities. It's always expressed as a composition of other activities. And this lets us get pretty far. But sometimes I may need to get my hands a little dirtier. I may need to drop down and interact directly with the runtime. So we have another unit of execution, and this is the most basic unit of execution. That's workflow element. Activity actually derives from workflow element. Workflow element, rather than expressing its execution logic as a set of activities, is going to express its execution logic in code. That means it's harder for me to look at it and figure out what's going on, because I have this compiled chunk of code that I'm going to run, rather than this collection of activities that we saw either in code or in XAML. But the reason that I might want to do that is if I want to interact directly with the runtime. And what do we mean by interacting directly with the runtime? Well, the workflow element has an execute method that takes in an activity execution context. The way to think about the activity execution context, this is the universe in which my activity instance is going to execute. It is the way that my activity instance interacts with the runtime. So by interacting with this activity execution context, I can do some interesting things. I can directly schedule activities. If I want to put something on the scheduler stack, I can go ahead and do that there. If I want to create bookmarks or resolve data, if I want to deal with some very low-level things like handling the ambient transaction or identity or reaching out to the host and doing some work, I'm going to write it there. This last item is also something that's pretty interesting, and I'll get to this in just a minute, but I can also set up to do asynchronous I/O. And that's kind of interesting in the parallel case, as we'll get to in a little bit. So let's go ahead and look at some custom execution patterns. And remember, the mental model to keep in mind for creating custom execution patterns is, I'm going to schedule some other work, and when that work that I've scheduled completes, then I'm going to make a decision about what I want to do next. And so let's look at my sequence. Were you to look at the source of the sequence that we provide, you would find something very, very similar to this. We do a couple of things, since we're doing this in code, that are a little different from activity. So I derive from workflow element. And there are two interesting methods that I'll get to before execute. And that's on get children and on get environment variables. And the way to think about this, about both of these, is these are saying to the runtime, hey, these are some pretty important things that I want you to manage. The way to think about this is adding this into the context of all of my activities, as my activity executes. But let's look at kind of the real piece of work here, which is the execution of the sequence. How do we think about what a sequence does? Well, if I've got 5 activities, I'm going to start with the first activity. When that activity completes, I'm going to move on to the next activity. Each time I do that, I'm going to check, hey, am I done? Have I reached the end of all 5 activities? And that's what we're modeling here. So you'll see we go and we say, give me the current place. If it's equal to the number of activities, we're actually done and we can return. For those of you who wrote custom composites in 3.0 and 3.5, I'm going to come back to why I think this is especially cool right here. Otherwise, I'm going to go ahead and grab the next activity that's in this collection that I want to execute, and then I'm going to say I want to schedule that activity, and I'm going to pass into it a completion callback. We zoom in and see the IntelliSense there. I'm passing in the completion callback, which is, as this thing I scheduled completes, execute this method. This is where I'm going to do the work of figuring out what's next. And the method that we're going to call is that same method of execute sequence. You also see this right here, where I'm incrementing the current index. And you might say, well, that's kind of silly. Why are you doing that after schedule activity? But one thing to always remember is that schedule activity returns almost instantly. Schedule activity is not blocking. It doesn't wait for the activity to execute. What schedule activity is going to do is create an activity instance and put that on this scheduler stack, which is the outstanding list of stuff the workflow runtime has to do. And so that's going to be all we need to do for our sequence to execute. So we're going to go ahead and switch over and execute the custom composites. I'd like to execute my sequence. And let's go ahead and see how we're actually invoking all of these. So all I'm doing, I'm saying I want to invoke my sequence. And because I haven't gotten to the part where we talk about how we write a designer for this, I'm going to have to do this all in code. But we'll get to how we build a designer for it so I can use it in the designer. But I'm going to create my sequence. And for the activities, I want to do 2 write lines. Write line, as you might suspect, writes out to the console window and says, hello world, and please enjoy the sessions. I'm going to do this. Wait for it. Hello PDC, and please enjoy the sessions. So the thing about sequence, that's the model to keep in your mind. I'm scheduling some work, and when that work gets done, I need to think about and see if I have anything else to do. Let's talk about something a little more interesting, and that's parallel. So we have my parallel activity. It's going to derive from workflow element. And this is just 8 times cool. All I'm doing in my execute is walking through each activity, and I'm scheduling that activity. One thing we heard pretty loud and clear from folks in 3.0 and 3.5 was this managing child activities that I schedule gets kind of tricky. I have to wire up events. When the events happen, I have to marshal that back in and think about this and then figure out if I'm done. Shouldn't the runtime just know about this? And the answer is it does now. So all I have to do, if I schedule these activities, when I schedule these, my parallel still has work to do, right? We know we're waiting on something because I've scheduled all of these child activities in parallel. As each of these complete, the amount of work that my parallel has to wait for gets smaller and smaller. And at some point, when all of these complete, we go back and the runtime looks at my parallel and says, hey, do you have anything else that you need to do? And my parallel is going to say, well, I don't have any outstanding children anymore. I'm done. And so what we've done here is the ability to schedule these activities in parallel, the ability to wait for things, has gotten a lot simpler. I don't need to worry about my callbacks here. And I've written a parallel executing activity in about one line of code. So let's go ahead and look at using this. Again, my mother, profoundly wise woman, always told me to use localhost for network demos. So that's what I'm going to do here. But all I'm doing, I have my parallel activity. Activities is the public property that I've exposed. And I'm passing in a number of these HTTP GETs that I'd like to execute. Then I want to point out something a little interesting about this async work, and so I'm going to do a little counting while this happens. So I'm going to execute my parallel, do a whole bunch of work, and we returned. This last line tells us what time we returned in, 412 milliseconds, and all of the individual activities also say how long did it take me to execute it. I want to drive this point home. The parallel shape, when used with activities that are written to take advantage of asynchronous work, will execute all of those activities in parallel. So if you note, if you add up the individual line items, they're going to come up to a lot more than 412 milliseconds. And we'll get into how do I write that HTTP GET activity to take advantage of the asynchronous programming model. So that's kind of interesting. That's how we're going to write a parallel. Now let's talk about writing some more custom control flow. And so what I want to do, I want to execute 3 activities. The first time I ran through this talk, I said I want to execute my children. And people pointed out to me I should probably think about some separate phrasing for that. So I want to execute these 3 activities. And when any 2 of them complete, then I'm done. I certainly want to cancel the other one and let him know he doesn't have to keep doing any work. But this is a pattern that we see pretty often. I want to send out 3 emails, and when 2 people tell me yes, I want to be done. And this is an example of something we could model with a sequence and a while and a bunch of if statements. But it's a lot more natural for me to just say, here is my first 2 of 3 activity, and these are the 3 things that I want it to do some work on. And so in the execute here, see, we schedule each one of those activities, and we also pass in the callback to onChildComplete. Now, we have to be a little more clever, because the runtime can't infer from the class name that after 2 of the 3 activities complete, I should be done. I need to actually express that in code. So the execute's kind of boring, but let's look at what happens on onChildComplete. Well, if the number that's completed is 2, what I need to do is I want to cancel my children, say to that remaining 1 guy, you can stop doing work, and then I'm going to be done. Otherwise, I simply want to increment that counter because only one of them is completed. Let's flip over and see what we've set up, what kind of work we've set up to do. So it's in the aptly named execute first 2 of 3. And you'll see here I have to switch away from this workflow invoker.invoke and go back to the more traditional model because I don't want to block the console while I'm waiting for somebody to type in. Because here's what I have to do. So I'm going to schedule this simple wait with cancel handler. We'll look at this in a bit. This is going to do kind of what you think it will. It's going to set up a bookmark, wait for a little bit of input. And the bookmark name that it's going to wait for is going to be the name that I print out. And so what I'll do, I'm going to resume that. I'm going to say, hey, go ahead and enter one of the names and print that out. And you'll see what I'm passing in are the names Bill, Steve, and Ray. Let's go ahead and see what this looks like when it executes. So my simple wait with cancel handler writes out the name that was passed in. It creates a bookmark saying, hey, I'm waiting here. And now I have to type in what I actually want it to do. So I'm going to say Steve. So Steve's going to complete. What we've done, we've looped around. We incremented the counter. We saw that we still have a little bit of work to do. Now I'll enter Bill. And so then Bill is completing. We looped around. We saw, hey, I've got 2. Now I need to cancel. And we'll see that simple wait with cancel is canceling for Ray. So this is where we hook up to that cancel handler. Okay. But now everything we've been talking about up until now is really the happy path, with the exception of somebody being told to cancel. We haven't really handled when something goes wrong. And you might remember in 3.0 and 3.5, if you thought about our activity life cycle, we had this faulting state, a faulted state, and then we moved to completed. And you might have been wondering where that went. And what we've seen is that we can actually create, on top of the activity lifecycle that we have now, really our own, whatever error handling pattern we want. Right? So the natural one for developers is try, catch, finally. And we're going to ship with a try, catch, finally in the box that's going to model the same semantics that we have in code of try, catch, and finally. But what I'd really like to do is, because I'm doing this network access, and my mom warned me about it, it's not always a sure thing. But I want to hide that from the user. I don't want them to have to put it inside of a while loop. What I'd like to do is create a retry scope. So what I'm going to do in my retry scope, you'll see I have one workflow element that we call action. I'm going to execute that. And I'm going to use the other overload of schedule activity, where its third parameter is this fault callback. So what I've done is I pass in a completion callback, which is just going to say, hey, I'm done. And I'm going to also pass in a fault callback. This is going to let me to deal with the fault as I would like to. If I didn't do this, I would start looking up at all the folks who had scheduled me, all of the parents, and say, do you know how to handle this fault? But I'm going to say, I know how to handle a fault. And the thing I'm going to do is I'm going to say, hey, wait, where are we at on the retry limit? Are we okay? Can we still keep going? If we are, I'm going to say, I have handled this fault. Whatever has happened, I'm taking care of it. I don't want it to keep going up. And what am I going to do? Well, I'm just going to repeat this. I'm going to go ahead and schedule that activity to execute again. And again, in the fault callback, I'm just going to say, hey, if you get a fault, go ahead and call back. Now, the interesting thing is what we do once we reach this limit. We don't do anything. We certainly don't mark that I've handled the fault, and then our default behavior returns. Nothing here knows how to handle the fault. It's going to keep going. So let's look at how we use this. So what I'm going to do, I'm going to create a new retry scope. I'm going to say I want the retry limit to be 400, because I really want this to eventually execute. And the thing that I want it to do, I'm going to go ahead and do a little more network access. And just to make sure that things don't go according to plan, I'm going to stop the web server. So my mom was wrong in this case. You can't always rely on localhost. And if I forgot, I did put a reminder here. So I'm going to go ahead and start executing. So what I do is I try and execute that Git website. And what we see is now we're going through and we're having this fault handler action. The fault handler action says, you know what? I know how to deal with this. I'm handling the fault. And what I want to do is go ahead and restart this. Reschedule this activity. Speaking of restarting, let's go ahead and restart the web server. And what you're going to see here, hey, now we're happy. We're back. And so what I can do with this is this allows me to give something retry scope to someone. They can put an activity inside of that, and they can configure how many times do I want to retry this? I don't have to force them to think about modeling it in terms of a while loop. I'm going to take care of that for them. Okay? So those are all the custom composites. We showed a couple of activities there, the async HTTP GET, the wait and cancel with cancel handler. And so the final thing that I want to talk about from a runtime perspective is really creating these long-running activities. And the pattern here, excuse me, the simplest thing we can do, I want to have a read line. And we said that we can walk out to this activity execution context and we create a named bookmark called readline. And then I'm going to set up a bookmark callback that is the thing that I want it to do when somebody walks up and signals that bookmark. Not going to do anything particularly interesting except set the outgoing variable to whatever value was passed in. And the interesting thing here is that I don't have to worry about returning an execution status. I don't have to worry about managing that execution state. The runtime knows, because I have a bookmark, that I still am waiting for something. And when that bookmark gets signaled, it knows that I don't have anything left to do. So the runtime is going to take care of this for us, and then our activity is going to complete. All right. Now, the other thing that we can do, so bookmarks can certainly be kind of one-time fire and forget, but it's possible that I might want to collect a number of stimuli to that bookmark. And at some point in time, for instance in this one, if someone types quit, then I'm going to be done. And again, you'll see here we're not kind of dealing with the execution status of the activity. I'm creating a bookmark callback, and then I'm passing in, you know what, I don't want this to be kind of the fire and forget, one-time use only bookmark. I want this to be multiple resume. Inside of our onResume, we're just going to say, hey, you're resuming, and then I'm going to look at that value that was passed in. If it equals quit, I'm going to close the bookmark. Now, when I close the bookmark, what's happened? Now this activity no longer has any work to do, so it's going to go ahead and close itself. But if I don't do this, if I don't type in quit, the runtime is going to look at this activity once onResume completes, and it's going to say, hey, you know what? You still have a bookmark. So you're going to stay executing. The final thing that I want to talk about writing long-running activities is this idea of writing asynchronous activities. Writing activities that take advantage of the asynchronous programming model. And this is one thing a lot of people asked us about in Workflow V1, and we'll get it as we talk about this, but they'll ask, is parallel multi-threaded? We would always say no. And people generally weren't very pleased with that response. Because what they wanted to be able to do is do a bunch of blocking tasks in parallel. And one of the reasons we didn't like to think about doing that is our runtime is very clever, and it's going to say if my workflow still has some things to do, I can go ahead and remove that from memory. Well, if I've scheduled a bunch of asynchronous callbacks, and when I try and call back the things living in the database, bad things are going to happen. Right? Those callbacks are going to have no place to go. I'm going to have no way to kind of route that error anywhere. And so we really kind of one of the strongest pieces of advice we gave activity authors in 3.0 was, you can write lots of code here, but do not start doing things like thread.sleep or spin up asynchronous work. Because we had no guarantees that that workflow instance was going to be there when we tried to process that callback. So what we do now, some of the improvements to the runtime have been to be a little more crisp about persistence and be a little more crisp about managing our workflow instance. And so we have this ability to walk up to context and say, I want to set up an async operation block. And what this does is it says to the runtime, I'm about to do some asynchronous work. I want to stay right here, pinned in memory. I don't want to move anywhere. This also creates some interesting things because we now can't really persist and take the thing out of memory, but we've explicitly said that's okay because I know I'm doing some asynchronous work. I want to be able to return those threads. I don't want to block threads if all I'm doing is a bunch of database access, right? Windows has this great I/O completion port infrastructure that takes care of all of this, and this is how we write really scalable things, is by taking advantage of asynchronous I/O. And so then what I'll do, all right, so we have web request, and I'm going to create that based on the value that's being passed in. I set up the async operation context, and then I use the APM. I say I want to begin get response. I go ahead and schedule a callback and pass a little bit of state in. It's important also that I make sure to complete the operation. And then what happens on that callback, I go ahead and take that iasync result. I pass it into, I then get the web request out. I pass that into my end get response. This is going to do all of the stuff to pull this back. This could also generate an exception if an exception happened off when I was trying to get this web page. But we're okay here because I'm explicitly saying if an exception happens here, I'm going to fault and somebody above me in the chain is going to deal with it. This is what we saw in that last example. As I tried to call end get response, I got that exception saying this host isn't found, and that got thrown up to my retry scope. And so this is a way that we can write activities that take advantage of the asynchronous programming model. And so if we're doing I/O, this is something we want to do. All of the activities that we ship that do I/O, things like services, things like database operations, take advantage of this. So if you take our built-in client operations and put them in parallel, you're going to get the behavior that you expect, and you're going to execute all of those in parallel. All right. So now we're kind of gone through a kind of a whirlwind tour of writing activities. I want to talk about writing activity designers. You might have noticed we've got a new designer from the 3.0/3.5 days. We took a long, hard look at how people were using the designer, and especially how developers were trying to customize the designer. And we said we want to do a little better. And so we're built on top of WPF, and this gives us a pretty nice base to build on top of. For anybody who tried to write activity designers in 3.0 and 3.5, you'll know our extensibility model was on Paint, which is a pretty great extensibility model. It allows you to do whatever you want, and you have to do all of it. As opposed to something like WPF, which has a lot of constructs for things like rich layout. We also decided we were going to split up the design time and the runtime. And so what this means is that you're not bound to a specific designer for a given activity. So if you have a better designer that you would like to use for the if-else that you want to surface, you can go ahead and write that, and we've got a little association store where you can override the association. We've got a couple of objects that are important. These are WPF controls that we've written, the workflow item presenter, the workflow items presenter, and the expression text box. I just want to give a quick tour of writing a couple of activity designers. All right. So the first thing that I would like to do is write a while designer. And you'll see, since we're building on top of WPF, we kind of get all of the WPF goodness. So that means I can use tools like Blend or the CIDR designer that's in Visual Studio in order to build my activity designer. And so what you see here, we have the while activity right here. All this is a workflow element designer. You can get one of these by doing right-click, add new activity designer, and we'll go ahead and spit all of this out for you. And the workflow element designer is kind of designed from the ground up to say, you know what, I am probably representing a workflow element. And then we use this thing that we call the workflow item presenter. And workflow item presenter is simply to create the hole in which one can place an activity. And so this is all I need to do to build a while designer. This is going to create a big target that somebody can go ahead and drag things from the toolbox and drop them on the canvas in order to represent the while. Now, one thing, I talked earlier about how people really tried to squeeze things into sequence and state machine and kind of did some funny things. One piece of feedback we got is that it was really hard to write custom activity designers for composite activities. And so we've thought about that a little bit, and let's look at building a sequence designer. And so here again, workflow element designer. Let me go ahead and move all this XAML up a little bit. What I'm going to do here is a workflow items presenter. So workflow item presenter is a hole where I can place one thing. Workflow items presenter is a drag and drop enabled control for handling collections. And you'll see what I use, and I forgot to show this on the last one, but the theory is the same, is that I can just use WPF data binding to point out what I want this to represent. So I'm going to say, hey, for the binding path, go ahead and walk up to model item.activities. Model item is simply the thing that the activity designer is designing. We have to do that because by default, the data context for a WPF control is going to be the control itself. And we want to actually be able to get down into the activity that we're representing. So I just want to say that's going to go up against activities. And then I provide a little bit of customization for I'd like to put PDC rocks. And let's go ahead and see what this looks like. So this is going to go ahead and fire up. And I want to point out that our sequence designer in V1, I went and I pulled up the code, and the lawyers made really sure that I didn't show it. But it's about 1,500 lines of code. It's about 800 lines of code in one type, and it's based on the composite activity designer, which is about another 700 lines. And it was really hard code. It was lots of layout, figuring off offsets, this from that. And so we've been able to, using the workflow item presenter, create a sequence designer in just a few lines of XAML. And so you'll see here, here's the while designer that I built. Here's an if designer that I built that uses the expression text box. And I can go ahead and rearrange all of these things. I can place my persist in there. And you can actually go and see the XAML here that's behind this designer. So you actually saw I moved the persist into the while. Let me close this. And I want to talk a little bit about the activity design, the expression designer. Because I know a lot of folks have probably done the labs, or they're going to take that VPC home and they're going to look and they're going to say, so these expressions are kind of interesting, but I'd really, this is kind of hard, right? I miss the warmth of IntelliSense that tells me when I hit dot what things are in scope, what things are relevant. And so we have an expression text box that's going to wrap this. This isn't in the bits that you guys have. But we had a dev working really hard last week to try and get this in, and I promised him that I'd show it, just so you believe me that it actually does work. I'm going to walk up here to a rule designer, and you can see we do have IntelliSense. So probably the next time we release workflow and the workflow designer, we're going to go ahead and have IntelliSense. That's kind of cool, I think. But again, I'm biased. So in summary, activities are the fundamental piece of execution in workflow. Activities are two things. They're data and they're work. And if you want to, you've got a wide range of control over the execution. The takeaway from here is write activities. There's one more thing that I'd like to show. Kenny alluded to this in his talk. And I want to talk about designer rehosting. So I talk about this idea of creating a constrained experience. This is something we had a lot of folks do in Workflow V1. And we had a pretty simple model for doing this. We had an MSDN white paper that was about 20 pages before the code examples. So it was really, really simple. Just grab that, go through it, and you got designer rehosting working. And we found a ton of people who were going through this and creating rehosted designers. So we really wanted to make it a little easier. I just want to show you a preview of kind of what it looks like. So here we just have a WPF form. I want to know there's nothing up this sleeve, nothing up this sleeve. I've just got some layout here. I placed a toolbox control just to save me a little bit of typing, and then I've got some grids that do things. Let's go and look at the code for this. So I was going to write this on the fly, but I apparently forgot to take it out. What I'm going to do, I'm going to do configure toolbox. Configure toolbox is just a little helper method here that's going to walk through all of my loaded assemblies and pull in all of the activities to put into the toolbox. You can completely ignore this. It just puts some things in the toolbox. I create a new workflow designer. I walk up to the one grid and say, I want to put the view in your child. I want to put the property inspector in another child. I do this designer metadata.register. What this does is this is all of the associations between an activity and an activity designer. And then what I want to show is I would like to capture the text changed event and write out the text. And then for my workflow designer, I'm going to tell it something I want it to load up. I'm going to pass it a single sequence. And so this is the code that's been written. And let me go ahead and execute this. And so wait for it. So we've been able to create a rehosted application here with a toolbox over here. I can go ahead and drop persist over here, or confirm over here. I can go ahead and flip back to the XAML, see the XAML, as well as walk up to any of these and get the property grid experience. So for those of you who've done rehosting, we think this is a little bit of an improvement. We'd appreciate feedback. With that, I really want to thank everybody for coming. I'd like to ask you, please fill out your evaluations. I really, really do take those seriously, so if there's something I could have talked about a little better, please let me know. We've got a number of activities around, no pun intended. We've got a number of other talks. We've got the Ask the Experts that's coming up very shortly. These are some of the talks that feature DubF. Got some websites you can go to. And again, I just really want to thank you. This is really... man, I'm really happy to be here. I'm so excited about the stuff we've got. Thanks, and let's talk about some questions. Yeah, you want to come up to a microphone? That way your voice will be recorded for posterity forever and ever and ever.
Let's say I have an application already, and we want to rewrite it now in workflows to use Dublin and all this stuff.
That's great.
But we've got also a really cool OR mapping from our database, and this is really cool. We don't want to lose that.
Okay.
And what about concurrency? Like I have now, let's say, 16 use cases, and I built those workflows, but if I let them run, then they will probably get the same object with the same ID and want to do something with this. And how do I protect that two workflows do not change the same piece of data at the same time?
So the question is about how do I make sure two workflows don't update the same piece of information at the same time.
Which is in the database.
Right, which is in a database. So in your activity, whatever activity you use to interact with the database, you're going to have to model that explicitly. You're going to have to do some check of a timestamp to see, hey, has somebody else checked this out or altered it since the last time I did it? The nice thing you can do, so the not so nice thing is that it's left as an exercise for you. The nice thing is that you can encapsulate that inside of your data access activity that takes advantage of all the ORM stuff that you're using. And once you encapsulate it, you can hand that for folks to use and use in their programs, and then they're not going to have to think about that.
So it's like custom locking, right? Mechanism I have to write.
Yeah, I mean, if you wanted to use, I mean, there's a couple different schemes, but they all kind of basically resolve around, hey, what's the last time I updated this? Oh no, somebody else has updated it. And so, yeah.
Thanks.
Hi there. For what I saw, it's like the designing activities using only SOML is kind of the preferred approach, and if it's that, I'm very happy. But the thing is, if you are developing new activities to be reused for different workflows or projects, or still the binary, the compiled DLL is the only approach, or?
Yeah, so so the question is a binary approach the way to go for encapsulating our types? And no, okay. Yeah, come on afterwards and we can kind of talk about it. We've got a couple of different scenarios there. Or just head on over and talk to Kenny.
Yeah, I guess that, yeah, there will be different things. For example, using a base workflow activity for common functionality and stuff like that is a similar scenario.
Yeah, you can certainly do that. Kenny, do you have anything you want to add?
Yeah, here, I'll share this microphone. So yeah, I mean, basically you have to remember, right, you can give a XAML file to somebody else, right? They can use that XAML file in their project, right? They can reference the activity defined by that XAML in their workflows. They can also modify that XAML file, right? So if you want them to not mess with your XAML file, if you're charging them, let's say, right, you want to have some sort of quality assurance, right, you get the signing and a lot of the benefits of just general .NET assembly redist purposes. But from a raw functionality perspective, you can certainly just distribute out the XAML file.
What about the backward compatibility?
What about what?
Backward compatibility with 3.0 and 3.5, a workflow 3.0.
Which functionality? The
Backward.
Okay. Okay. Right. So Kenny talked about this a little bit in his talk. And the way that this works is if you have an activity written in 3.0, in 3.5, it's going to work. We have an interop activity that's going to call from the 4.0 runtime to execute that activity. And definitely follow up with us afterwards to talk about that. In addition, it will also, all of your activities will continue to work and your workflows will continue to work. We're going to ship the 3.0 and the 4.0 runtime side by side.
Hi. Same question as 3 years ago. And it looks like you may have solved this. Is the state machine flow now capable of supporting composite states as state machines? So it used to be you could only have state machine as a root. Thank God.
Yes.
Okay.
Yeah. Yeah. So we don't have a state machine designer yet, but we're one to go and look at the OM. You know, we've got it in there. You can build them in code. And
all right. Quick question then. Default state going into the substate. So
we can follow up on details of the state machine online, and I'd love your feedback.
okay.
Yeah. That's the other thing. Definitely look at stuff and give us feedback. You know, and we can kind of make some adjustments there. Yeah.
Will the designer run under partial trust?
Will the designer run under partial trust? Right now, it won't. In a full trust setting, we have it executing in an XBAP, so inside of a WPF browser-hosted application. Let's talk. Right now, I don't know if we're going to get to do the partial trust work, but I'd like to know a little bit more about your deployment scenario and the restrictions there.
Okay, thank you.
Yeah, very good point. The runtime is partial trust enabled, so it will work in partial trust settings.
Thanks.
Question in the back.
Yeah, you mentioned the parallel activities are running in memory, so the callback, the workflow can be also in memory when it completes. What if those need to be durable or they're long running?
Right, so if they're durable or long running, if we don't do that, so I kind of did some magic little invocation where I said this setup async execution context, which was the special signal that says, hey, keep this thing here. The normal behavior, if I were to have a send message and a receive message activity, we're going to go idle and we're going to persist, and then whenever that receive happens, we're going to return. Even with the read line that I have that is, you know, waiting for some console input, that if I have 25 of those in parallel, once all the bookmarks have been set up, I don't have any work to do, and the runtime can go ahead and extract me to the persistent store. Okay.
When can we expect next beta?
When can we expect the next beta? I don't know. They don't pay me nearly enough to talk about dates. But right now, in the bits, on the Oslo VPC, you can go ahead right now and go in Visual Studio 2010 and do right-click New Project, create a new workflow project, and do just about everything that I showed up here, with the exception of the expression text box. But everything that I showed is built on top, basically on that Oslo VPC.
In this version, is anything easier to build custom services like persistence or tracking services?
Yes. So the question is is there anything easier about writing persistence and tracking services?
Yeah, or extending maybe the existing ones. Maybe.
So extending the existing ones. Come on to the Ask the Expert so we can kind of dive into that. The short answer is we've simplified the amount of things needed to do, for instance, to implement a persistence provider. We don't have, like I think the persistence service in 3.0 had about 7 or 8 methods you had to override, and there were kind of some weirdness about timers and things like that. We've gone ahead and made that a lot simpler. And come on down and we can pull up some code and show you how you do that.
Okay, thank you.
Yeah, in the back.
Since the designer is now based on WPF, would it be possible to host it in Silverlight?
Would it be possible to host it in Silverlight? So what I would say to this is we're not going to get to that in Visual Studio 2010. We've heard loud and clear that people are very interested in the web-hosted scenario. And it's definitely something I have as a pretty high priority item that I want to get to. Right now, we're really focused on kind of rounding out all the activity designers, making sure we get a state machine designer and things like that. So I guess the answer is it's not on the it's not in for 2010, but it's certainly something we want to get to. It is an opportunity, yes. I will promise, just about everybody on my team will link to your blog if you blog a sample Silverlight Workflow Designer. And if there are other things that I can entice you with, let me know. Matt Milner will probably also link to you. Anything else? Head to the Ask the Experts. Have a great PDC. Thank you. Come on up if you got anything else.